So on this evaluating and solving formulas, really all we're doing is replacing a value in wherever it tells us to put it. For example, on this one, right, we got this is z. That's what we'll solve for, z equals x minus, I forget that Greek symbol, and I'm sure you don't care about it either. And that one as well, but in any case, we're just going to replace those with the values they give us. So, for example, x is 80, so I'm going to replace x with 80. And then we'll replace this one, I'm trying to color code these by the way. So this one with 100. And then this bottom symbol here with the 15. So evaluating this, we've got 80 minus 100, which is negative 20. And this is over the 15 still. I guess the fraction or the decimal will work. In any case, we can simplify this to be negative, dividing both these by 5. Gives us negative 4/3. And then as a decimal, we would have negative 1.3 repeating. So either one of those will work. I kind of prefer the the improper fraction there. So I would just keep it like that. That way we get to avoid a step right there. I mean, this one's bigger, right? But it's the same idea. We have an a value, which is 4, so we'll just replace all the a's with 4. Anywhere where we find one. And then, of course, b is negative 2, so we'll make this negative 2. Now, everything else stays the same. So if we got a minus, it's there. If we got parentheses, they're there as well. And then any other numbers that were in there. And this is all just order of operations stuff from here. So evaluating the parentheses, we got 4 plus negative 2, which is 2, and then 3 minus 4 is negative 1. So we've evaluated the parentheses, and we still got 4 minus the stuff. So using multiplication now, 2 times negative 1 is negative 2. So this ends up being 4 minus negative 2, this j. And 4 minus negative 2 is the same as 4 plus 2. So j ends up equaling 6. That becomes a plus. Of course, you could plug that in your calculator as well. Same idea. These types of problems are considered plug and chug because you're just plugging it in. And then the calculator will kind of chug it for you there. But of course, we should see some work. So here's a little difference because they wanted us, since they told us in the hint to convert time to hours, that means that, well, we can't just make this 3 hours, 48 minutes. So we'll need to change that into just hours. So we got 3 hours, 48 minutes, and 48 minutes will become hours. We'll use dimensional analysis for this as well. So 1 hour is 60 minutes. And I'm just going to go to my calculator on this thing. Rate divided by 60.8. So really, this is 3.8 hours. Now the distance was 121 miles. And we can see from here that distance is the rate divided by time. I'm sorry, the rate times the time. And right now we're trying to actually figure out the rate. So I guess that doesn't really help us. Unless we were solving an equation, right? So the distance was 121. We can do it that way. Which is equal to the rate, which we don't know the rate. But we do know the time is 3.8. Alright, so to solve this one, we'll have to divide both sides by 3.8. And then those cancel out. So in the calculator, 121 divided by 3.8. And I get, on my calculator, 31 point, didn't tell us where to round. We could make it 84 miles per hour, or mph. But I'm going to start with number 5 on this one. So we get a January day at 22 degrees Fahrenheit, which is, what is the equivalent Celsius temperature? And they gave us this formula. That may be easier to see. So we'll figure out the Celsius temperature from this stuff. And I'm just going to rewrite this equation. And right there, they gave us the temperature in Fahrenheit, which was 22. So I'm just replacing the Fahrenheit temperature with 22. And continuing to evaluate this, we got 5/9. 22 minus 32 would be negative 10. And this ends up being negative 50/9, which comes out to negative, let's see, negative 5.5 repeating, I think. So 22 degrees Fahrenheit is the same as negative 5.5. Well, I guess we could round it. Yeah, we could round that. Oh yeah, it says to round to the nearest whole degree. So we would have to round this to negative 6 degrees, and that's in Celsius. There it is. All right, number 6 right here, it gives us the formula for the area of an open box. And this is important to remember because the area of an open box is very different from a closed one. Specifically because we have to determine if it's which of the faces or surfaces of the box we are not including. In this case, we can see from this formula here that it's 1 of the length times the width, so that should be the base of that box. Now up here we see the length is 3, the width is 9, and the height is 7, so we're just going to go in and replace all of those. So the area is 2 times the length, which is 3, times the height, which was 7. Then we'll add that to 2 of the width, which is 9, and multiply that by the height, 7. Then we'll add the length, which is 3, and multiply that by the width, which is 9. And from here, we're just looking to evaluate these. So 2 times 3 times 7, that should be 42. And then 2 times 9 times 7, I better double check on that one, times 126. And then 3 times 9 is 27. So we just need to add these together. And the surface area of that box, 126 plus 42 plus 27, 195. And those were in centimeters, so we could say square centimeters. All right, the trapezoid, we have that area formula, which is 1/2 of the small base plus the big base times the height. And over here in this trapezoid that it gave us, it really doesn't matter which is which, but this is the smaller base, which came at 5.4. So I need to replace that base with 5.4. And then the big base is 13.5, and then the height of this thing is shown here. That would give us a 90-degree angle, so the height is going to be 10.8. So I'm just going to replace those in that equation that it gave us. The two bases are the two sides that are parallel from each other, and we can see from this side and this one that they're kind of coming together. They'll eventually, they're not parallel So yeah, thanks for pointing that out. The two bases particularly are the parallel side lengths of that trapezoid. Alright, so just evaluating this thing. We haven't done anything with the 1/2 yet. We will though. But inside the parentheses, 5.4 plus 13.5, I got 18.9. And then we'll multiply that by 10.8. So looking at this, I'm just going to plug it right into a calculator. 1/2 times 18.9 times 10.8. So I get 102 point, didn't tell us where to round as far as I can see. So I'm just going to write the whole answer, 0.6. And this is area again, so this is in square centimeters. So this one, it tells us that the area is this 1350. And we need to be aware of that so that we replace the right thing on this. And then it didn't tell us what the length was, but it did tell us the width is 30 feet. So to solve for the length, we're going to divide both sides by 30, which leaves us with the length 1350, 45 feet is the length. All right, number 10 is going to work the same way, except for there's no reason to divide like we did on this last one. So we're going to replace the x with this -4 stuff, and the rest of it just stays the same. So evaluating this, we'll do multiplication first, so -12, and then plus the 3. And then combining these, we get -9. So y equals -9 when x is -4. So on number 9, again, we'll replace the x with the 2. So again, this x now becomes 2. Everything else stays the same. And then we do 6 times the 2, which is 12. Everything else stays the same. And then let's get rid of that 12 so that we get the y's by themselves. And then finally, we'll divide both sides by 5. And we see that y equals 2 when x is 2.